So now what we are going to do is analytically find the profiles of cams. The graphical methods in the book we are not covering, so don't submit that on assignments and homework. First we will do the flat face translating follower. This is the translating follower. There is an offset. It is important for determining whether it can move under whatever friction there is, but in terms of kinematics you see it will not be important. This distance L, I will remind you, we have previously found it. It is y prime of theta. Now we will come here. This is the contact point, and now this point S has rotated by an angle. It has moved through an angle theta over here. When S was here, that is when this follower was at the lowermost point. That is why y is measured from here. This is the base circle radius that is fixed. It is a part of the cam design, and so this distance OB is here, RB plus y, and the distance AB is equal to L, is equal to y prime of theta, and the tangent of this angle, which is theta c minus theta, is something. Therefore, theta c minus theta is tan inverse of AB by OB, and that basically gives us this expression, because AB is L, OB is RB plus y of theta, and L itself is y prime of theta. That gives us theta c. You see, parametric in terms of cam rotation theta, and over here RC is just square root of AB square plus OB square, and we just substitute those in. We have RC, that's the cam profile. As simple as that. Using this, so suppose I tell you what the cam displacement profile is, what y needs to be as a function of theta, and I tell you some other things, you should be able to compute an acceptable cam profile. Okay. Now here, this is the next one. This one is a little more complicated. This is the translating roller follower. So this is the translation. This is the roller. Over here also, there is an offset, and the offset is a part of the kinematics. The roller has a certain radius. Remember that this is the trace point. It, relative to the cam, it travels on the pitch curve, which is here, but this here, this inner part, this is the cam profile. There is a base circle which is given by the cam profile itself, and there is the pitch circle which is given by the cam profile radius plus the roller radius. Okay. Now, when this point U is important, when this point V was at U, then this trace point P was at its lowermost point P0. Okay. Remember that this distance from here is the same as the offset E. Point U has traveled through this angle, which is theta. As a result, this trace point has risen by a distance y. Okay. Now you look here, there are a couple of other angles. This is, we will use a different color to help you notice what we are doing. So here is one curve, one angle, which is from here coming here. This is theta p. This is the angle which leads to the trace point, but the actual contact point is here. That angle is a little different. That one is theta c. To locate a point on the pitch curve, it is good to find this point, and we will do that. But to locate a point on the cam profile, it is better to find this point here, which is called A, and we will find that as well. But let us do the first one. So the tangent of this angle, which is theta p minus theta. this is theta. See, this is theta. So theta p minus theta is tan inverse of BP over OB. BP is the offset. OB is equal to this height which we have calculated in the previous lecture plus y. There it is. Theta p minus theta equals tan inverse. So the theta has been brought over to this side is equal to tan inverse offset that height and that y. Okay. Similarly, OB and PV can be used to find the distance r. What is the distance r? That's the distance r. Let me show you in green. That's the distance r. So it is the square root of PB square and OB square. Okay. So we've got r directly from here. Easy. But as I explained, we need the profile of the cam. And so what we do now is we look at this angle, which is theta c. Let me choose yet another color. This time, what should I use? I'll use this color. So now I have this angle theta c, from which I subtract theta, and then the tangent of that is this distance by this distance, but this distance here is just this old distance plus the roller radius times the sine of the pressure angle. So here we are, this was the old distance, to that we have added roller radius times the sine of the pressure angle. In the previous lecture we have found what the pressure angle is, that same pressure angle. We know that in terms of various cam parameters. So you can see that there is a complicated dependence, but we have an explicit relationship. Okay. Similarly, this distance which was this one plus this one, from that we have to subtract now roller radius times cosine of pressure angle, and so here we have that distance here, that square root distance plus y minus roller radius times cosine of pressure angle. That gives us theta c, that is a point on the cam profile. It is given in terms of this parameter theta. Phi itself depends on theta, y of theta in various ways. And similarly, RC, the point on the cam, is given by the square root of this one squared, which is here, plus the other one squared. Okay, and so we have closed form analytical expressions for the cam profile. There are other types of cams and other topics discussed in the book. Those are not covered in this lecture or in this course this semester. Thank you.